Right now, in every country on Earth, in every classroom and every calculator, people write numbers the same way. 10 digits, 0 through 9, shifted into position to build any value you want. That agreement is actually the exception in human history, not the rule. For most of civilization, if you wanted to write 347, which symbols you used, and whether the system could even handle that number cleanly, depended entirely on which river you happened to live near. Start in Mesopotamia, around 2000 BCE. The Babylonians built one of the first positional number systems in history, meaning where a symbol sat mattered, not just what it was. But they didn't build it in base 10. They built it in base 60. That's not a random choice. 60 divides evenly by 2, 3, 4, 5, 6, 10, 12, 15, 20, and 30, which makes fractions and trade math dramatically easier than base 10 does. You're still living inside that decision every single day. 60 seconds in a minute, 60 minutes in an hour, 360 degrees in a circle, all Babylonian, all 4,000 years old. Their number symbols were wedge marks pressed into wet clay with a reed stylus. And this is the part we covered in an earlier video. For centuries, they had no symbol for an empty position at all, which meant 2 and 2-0-3 could look identical on the tablet. It took nearly 2,000 years before Babylonian scribes added a placeholder mark to fix it. Egypt, working almost entirely independently, took the opposite approach. Egyptian numerals were additive, not positional. You just stacked up symbols and added their values together. A single stroke meant 1. A heel bone shape meant 10. A coiled rope meant 100. A lotus flower meant 1,000. Position on the page didn't matter at all. You could write the symbols in almost any order, and the value stayed the same, because the system never needed to distinguish in the tens place from in the hundreds place. The trade-off is brutal for big numbers. Writing 999 took 27 separate symbols, stacked and counted by hand every single time. Rome inherited a version of this same additive logic, and it's the system most people have actually seen without knowing its limits. I, V, X, L, C, D, M. No zero, no place value, and for centuries, no subtraction trick either. The version everyone recognizes today, where IV means 1 before 5, came later. The earliest Roman numerals just piled up 4 I's in a row. Multiply 2 large Roman numerals together sometime, and you'll understand immediately why Europe eventually gave the whole system up. We covered exactly why doing long division in Roman numerals is a special kind of nightmare in an earlier video. And Rome ran an empire on this for the better part of 1,000 years anyway. Meanwhile, completely isolated by an ocean, Maya scribes built something structurally more advanced than anything happening in Europe at the time. Their system was positional, like Babylon's, but built on base 20 instead of base 60. Dots for 1 through 4, a bar for 5, combined to count up to 19 before shifting position. And critically, by around the 4th century CE, they had a real symbol for 0, a small shell shape used constantly to mark an empty position in their calendar system, independently of anything happening in India at the same time. Buckle up, because China took an entirely different physical approach to the same problem. Not carved stone, not ink on papyrus, but a system you could hold in your hand and rearrange in seconds. Chinese counting rods, in use by at least 200 BCE, were small bamboo or bone sticks laid out on a counting board in a genuinely positional base 10 system. And as we covered in an earlier video, they were also one of the first number systems on Earth to represent negative values cleanly, with red rods for a gain and black rods for a debt. You could physically pick the rods up and move them, which made China's system faster for real arithmetic than almost anything happening in the Mediterranean world at the same time. And then there's the strangest entry on this list, because it wasn't built for trade, taxes, or astronomy at all. In 1679, the German mathematician Gottfried Leibniz worked out the rules of binary, every number expressed using only 0 and 1, largely as a philosophical exercise, drawn to the idea that all of mathematics could be built from nothing and 1.
Here's the part that should mess with you a little. Over 20 years later, a Jesuit missionary in China sent Leibniz a diagram of the I Ching, the ancient Chinese book of changes, built from 64 hexagram patterns of solid and broken lines. Leibniz looked at it and realized the hexagrams matched his binary system exactly, counting from 0 to 63, a structure that predates him by thousands of years, discovered independently for entirely different reasons. Binary sat as a philosophical curiosity for over 2 centuries before it became the literal foundation every computer, phone, and this video itself is built on. 6 systems, 6 completely different logics, base 60, no place value at all, subtraction is a trick, an independently invented 0, physical rods you could rearrange by hand, and a binary code hiding inside a 3,000-year-old divination text. All of them solved the exact same problem. How do you take a quantity that exists in the real world and trap it accurately on a flat surface? We just happen to have all agreed, for now, on one particular answer. You made it to the end, which means the exit fee is due. 1 subscribe. That's the toll. I'm flipping this tablet around like I'm expecting a tip on a bottle of water, and you're paying it in the form of a like. Don't, and I'm assuming your MHC molecules are incompatible with mine. And honestly, things are about to get real awkward between us.
Stay wrinkly, apes. See ya.